the concept of square root lends itself to what we call imaginary numbers. Now, the idea when you take the square root of a number, you should always get a positive answer. Now, that kind of becomes an issue when we ask ourselves, well, what happens if we take the square root of a negative value? Like, what is the square root of negative 16? Well, in the real number sense, there's no number times itself that would be negative 16. No real number, we should say. So therefore, we can't really answer that. And in Algebra 1, you answered this question by saying not possible, or, it's a bad question, or no solution. You wouldn't say no solution, but you're just saying that's not possible. And it's not possible if you're only working with the real numbers. The proper way to answer this would be, what's the square root of negative 16? It's not real, right? So what is it? Well, it's imaginary. Square root of negative 16 is what we call an imaginary number. So with the imaginary numbers, there are two definitions that we have to follow here. Okay? The first thing is when you take the square root of negative 1, now there's no real number that multiplied by itself will give you negative 1. So this, is not possible in the real numbers. So what we say is, let's call this an imaginary number. Just say every time we see the square root of negative 1, we'll call that I, and everything else will stay the same, right? So now there's a second definition that we'll see here momentarily. When you take the imaginary number I to the second power, we're going to say that equals a real number, negative 1. So the square root of negative 1, we're going to replace with just the letter I. So every time you use this variable I, make sure it's not just some variable. I shouldn't have said that word, variable, but it represents that imaginary number. So do not use this as a variable, I guess is what I should be saying. And I to the second is negative 1. All right, so how we apply this, it's actually not all that difficult. So if we take an example like we want to find the square root of negative 9. Well, we're going to use the same idea we did when we were simplifying with, a positive radicand. So what we're going to do is we're going to say, well, what is the square root of negative 9? We can think of it as the square root of negative 1 times positive 9. Right? And then we can split this up into two parts, just like we did when we were simplifying square roots. So what you can see I did, I separated into negative 1 times 9 because eventually I want to separate the square root of negative 1, which I'm just going to call I, away from a normal radicand, square root of 9, which is this 3. So this is I, and of course this is what it's always been, 3. So it's I multiplied to 3, or we would just simply say it's 3 times I. So square root of negative 9, we're saying is 3I. 3 times I is an imaginary number. And likewise, we could conclude that if I took 3I times itself, I should get a negative 9. Right? And I do. Okay, this one, again, let's not concern ourselves with this negative 1 being multiplied out in front, but let's split this up. Negative 1 times 25, or negative 1, square root of negative 1 times the square root of 25. And then take this apart. We'll say you are a negative right there. You are I, and you are 5. So it's negative I times 5, or simply negative 5I. Okay. Number 3, again, the plus or minus just means we want both the positive and negative principal square root here. So again, it's imaginary. How do I know? Because we're taking the square root of a negative value. That's imaginary. So what we can do is we can split this up into, let me take this a little bit slower. Let's call it negative 1 times 4/9, all in your radicand there. Now split them up. So we get plus or minus the square root of negative 1, and we'll do times the square root of 4/9, which we know is square root of 4 over the square root of 9. We can split up fractions like that, our division rule. Okay, so that'll still be plus or minus. We will get an I here. Square root of 4 is 2. Square root of 9 is 3. So all things put together properly, since I'm running out of room, I would say plus or minus, let's write the fraction 2/3 and then tack on that for the I. Right. Number 4 is 5, no big deal. But the square root of negative 4, again, we'll split that up into the square root of negative 1, square root of 4. Square root of negative 1 is I, so 5 times I, square root of 4 is 2, so you have 5 times I times 2, more simply written as 10I. That will be our final answer. Okay, so you can see it's not that much different than what we were doing with, positive radicands. It's just we have to attach an I. I don't want to boil it down to this simplicity, but you could say the square root of 9 is 3. Well, the square root of negative 9 is 3I. Negative square root of positive 25 is negative 5. Negative square root of negative 25 is negative 5I. And you can basically just ignore the negative and attach an I at the end. But I think that kind of simplifies it a little bit too much, and we can get in trouble doing that sometimes. But really, in essence, that's all that's really happening here. Okay, now number 5, why is this one different than the others? Well, because when we split this up, square root negative 1, square root 75, the square root of 75 we have to simplify just like before. So let's say square root of negative 1, and then we look for the largest perfect square that divides into 75. The largest perfect square would be 25. So we say that's the square root of 25 times 3. 25 times 3 is 75. All right, then part by part, that gives me I. That's the square root of negative 1 by definition. The square root of 25 is 5. And the square root of 3, well, not much you can do about that. So cleaning this up, how I usually write this, some books will write the I in back of the radical, which I understand that concept. But when we're writing things out, we don't want to assume that or make it look like the I is underneath the square root. So I'm going to write the 5 first, then the I, then the square root of 3. It's just instead of how a book would probably write this. They would probably write 5 square root of 3I, which is not wrong, but sometimes when we write things out, we get a little sloppy and, extend that a little too far, and, it might look like that it's 3I as your radicand when the I is not underneath the square root. So we'll just be careful in that respect, and I'll write it this way every time. So we'll put the I in front as opposed to in back of the square root. Okay, same idea here. We'll save the 3, not much you can do there. Split up negative 54. Let's split it up 3 ways. First of all, take out the imaginary part, square root of negative 1. 54, largest perfect square, I believe, is 9. And we'll split that up into 9 times 6 is 54. All right. So, clean this up. You got 3. You got I. You got another 3. And you got the square root of 6. So, it's 3 times I times 3 times the square root of 6. We would say this is 9I square root 6 for our answer. Again, putting the I in between the 9 and the square root. Okay, well that brings us to a problem like 7. Sometimes we don't have square roots of negatives. Sometimes we just write them as their imaginary form. And we can actually multiply imaginary numbers together, and here's where the second part of the definition is going to come into play. So they want you to multiply 11I times 3I. Well, to start off, it's really no different than them saying, what's 11x multiplied to 3x? Right? In essence, to start off with. Now, I is not a variable. I is very specifically representing the square root of negative 1. A variable could represent any value, right? Like 11x. X could represent any value. But if you took 11x times 3x, you would say that's 33x squared. Well, likewise, we can treat these imaginary numbers the same way. 11I times 3I, we can call it 33I squared. Now, when you're talking variables, that's your answer, 33x squared. What else are you going to do? But when you're talking imaginary numbers, you should never have a power on your I other than 1, because every power of I can be simplified to something else. So we just go to our definition. I to the second is equal to negative 1. We'll replace I to the second here with a negative 1, and we'll say this is 33 times negative 1, or negative 33 is our answer. So kind of weird stuff here. When you multiply two imaginary numbers together, you can get a real number. In this case, we did. Now, when you multiply two real numbers together, there's no way you're ever going to get an imaginary number. So we'd have to be careful, going the reverse way. But for this problem, they can write it in terms of i's, which means they can also have you do multiplications when they have the actual square root symbol. So let me give you a sample of that because this one can be very easy to miss. Right, I guess we're up to number 8. So let's say we had something like the square root of negative 16, and we want to multiply this by the square root of negative 4. Now, here's the problem. We can't simply multiply these two numbers together as radicands. Square root of negative 16 times the square root of negative 4, we can't say this equals, don't write this. We cannot say this equals the square root of 64 because it does not. The problem is you're applying real number techniques to imaginary numbers, and that's a problem. It doesn't mix in this case. So we can't just multiply our radicands. What we have to do is write this as their imaginary numbers in terms of I, and then we'll see that we're not going to get the square root of 64 or 8 for our answer. We're actually going to get the opposite of that. So the square root of negative 16, again, we simplify it this way. Square root negative 1, square root of 16. Simplify this one, square root negative 1, square root 4. So we have an I here, a 4 there, another I, and a 2. Okay? When we multiply these together, I times 4 times I times 2 would be 8I squared. And again, going back to this, I squared is negative 1, so unfortunately, you got to go through this mess to get the answer. The correct answer is negative 8. If you multiply the radicands to begin with, you're going to get a positive 8, which is definitely not the case. Negative 8 is our answer, not positive 8.